All right, guys, now we have an interesting question on the board. So the question says, a block whose mass m is 40 kilograms is pushed across a frictionless surface by a light iron rod whose mass is 4 kg. The block is moved from rest a distance d equal to 80 cm in 2 seconds at a constant acceleration. Now the question says, what force must the hand apply to the rod? B, what force does the rod push the block with? C, what is the net force on the rod? Now this question to me is very interesting. The question, to solve it, you need to apply both Newton's second law and Newton's third law of motion. Now let us clean the board to have a solution for this question. So the mass of the block is 40 kg and the mass of the rod is 4 kg. All right. So now let us have a free body diagram. Now this is the block. This is the block, which is what? 40 kilogram. Now this is the rod. This is the rod. The rod is 4 kg. So this is the applied force, Fa, on both the rod and the mass. Now this is the surface, the frictionless surface, okay? That is a surface whose friction is what? 0. Now, you see, as this force is being applied, remember, the force is pushing both this mass and this mass. So let us write an expression for the net force. Now, F net, the net force, is equal to what? The applied force minus the frictional force is equal to what? Mass times acceleration. But this mass, is a combined mass. The mass of this rod and the mass of this block. So we will have this. See what we have now. We have the capital letter M is for the block, while the small letter m is for the what? Rod. So m, that is the combined mass, m plus m, then times what? Acceleration. So this is the equation for the net force. So since Ff is equal to 0, we now have that. F net, the net force, is now equal to what? The net force will now be equal to, that is bracket capital letter M plus small letter m times what? A. Okay, so this is the net force. Yes, this is the net force. So now, remember, we are, this net force is equal to the applied force. I hope you understand. If you put 0 here, if you clean this is 0. You see it now. I've cleaned it. You see, it's equals to the applied force. So take note. So now, we now have that F net is now equal to what? 40 plus 4, then times what? A. Now, remember that they did not give us the acceleration, remember. So you need to find the acceleration. Now, to find the acceleration, we make use of this formula. We make use of this formula to find the acceleration. We make use of the distance formula. Remember that the distance is equal to what? 80 cm. So if you convert it to meters, it will be 80 times what? 10 raised power minus 2 meters. 10 raised power minus 2 meters. So which is equal to 0.8 meters. Yeah. So and the time is equal to what? 2 seconds. The time is 2 seconds. So from this equation, from x equals to ut plus 1/2 80 squared. U is equal to 0. Okay? So we now have 0.8 is equal to 0 times 2, then plus 1/2 times a times 2 squared. So we now have 0.8 is equal to this is 0 now, okay? that is 4a over 2, which is equal to what? 2a. So 0.8 is equal to 2a. So therefore, we now have 0.8 is equal to 2a. Therefore, a is equal to 0.8 over 2. A is equal to what? 0.4. 0.4 meter per second squared. So this is the acceleration. 0.4 meter per second there squared for the acceleration. Okay? So now that is it. So when we substitute it here, we now have that the net force will now be equals to what? 44 times 0.4. So 44 times 0.4 will give us, it will give us, that is, 44 times 0.4 is 44 times 4 over 10. Okay. So which is, 4 times 40 is what? 160. 4 times 4, 16, which is what? 176 over 10, which will give us what? 17.6. So the answer for the applied force is what? 17.6 newtons. This is the answer for the applied force. I hope it's very, very clear. 17.6 newtons. That's the answer. So the second question is, they ask you, what force does the rod push the block with? The force that the rod push the block with, look at the force here. So the force is, that is, the rod, this is the block, and this is the rod. Okay? So this is the applied force, FA. So this, they ask you, what force does this rod now push this block with? Do you understand? So we are concerned with this contact force here. Do you understand? So clearly the force is F. So in this case, let's call it F, force on block due to rod. Okay? FBR is now equal to mass of the block times what? Acceleration. That is it. So we now have that FBR is equal to what? The mass of the block is 40, remember? 40 times what? The acceleration is 0.4. 40 times 0.4. So 40 times 0.4, FBR is equal to 40 times 0.4. That is, which is 160 over, so that is 40 times 4 over 10. So cancel. The answer is what? Is 16. That is 16 newtons. Okay? 4 times 4, 16. Cancel 0 here. So it is what? 16 newtons. This is the answer. 16 newtons. Okay? So the final question now, they say, what is the net force on the rod? So the net force on the rod will be, see, the applied force is going to the positive x-axis. Why? According to Newton's third law, if the rod is pushing this mass, this 40 kg mass, according to Newton's third law of motion, this 40 kg mass will be pushing this rod back. Do you understand? So towards the negative x-axis. This one is positive. This one is what? Negative. So now it becomes on the rod. The net force on the rod becomes, that is F net is equal to F net on rod is equal to what? The applied force FA minus what? Minus this force now. This force I just calculated minus FBR. So the net force on the rod will be, look at it here. So it will be equals to, that is the applied force is, what do we get in the applied force again? I've cleaned it. So I think 17.6, right? Yeah, 17.6. Yes, 17.6 minus 16. Yeah, minus 16. So which is equal to what? Which is 1.6 newtons. So this is the net force on the rod. So you see that the question is kind of interesting. I hope it's very clear. And so see you guys in my next video.